Welcome to chemistry class. Today's topic is Vander Waals equation of states. We all know about ideal gas equation, which is stated as PV is equal to RT for 1 mole of gas. So, if a gas follows this equation or the parameters of this equation under any conditions, it is said to be ideal gas. We know that. So, but in practice there is no ideal gas. So only just hydrogen behaves like ideal gas in at the particular point, but it also not to be considered as ideal gas. So then the Vander Waal, a scientist, checked the ideal gas equation experimentally, and then he proposed a modified ideal gas equation, which is called as Vander Waal equation of states. See here, that can be written as P plus A by V square into V minus B is equal to R. So, this is said to be Vander Waal equation of states. Let us see what he did. He added A by V square to the pressure, which is represented in ideal gas equation, and he subtracted this much of volume from the volume given in ideal gas equation. Okay, let us see why he did so. So, correction of pressure. So, when you consider a gaseous molecule on the surface, it will experience pressure towards this direction, but it never experiences pressure from this direction. Is it clear? So, when ideal gas equation proposed, the pressure considered as the force experienced by the gaseous molecule uniformly. But in practice, the molecule which is present on the surface will experience more attraction, residual attraction. So then, while discussing about pressure of such molecule, that much of residual pressure experienced by that molecule also to be incorporated like this. This is to be considered as correction in pressure. Correction in pressure. When about volume, correction in volume, when you consider a gaseous molecule as a sphere, see here some extent of volume is excluded. This is not utilized by the gaseous molecules completely. So, the ideal value should be reduced. Okay, is it clear? So, these gaps left over while the gaseous molecules accommodated in a container. Okay. So, now he has considered this molecule, this volume, unoccupied volume by the molecules as small v. This is called as Vander Waal constant. B is called as Vander Waal constant. Let us see, like this pressure also, he has considered that much of attractive forces experienced by the surface molecules additionally like A by B square. Okay. So then he incorporated these modifications in ideal gas equation. So that is, the pressure has to be increased and volume has to be decreased. Okay. So he incorporated the additional attractive forces experienced by the surface molecules. Then he modified the pressure like P plus A by B square, and he has taken the unoccupied volume under account, and he reduced the volume by subtracting the unoccupied value like this, B minus B is equal to RT. So this is said to be Vander Waal equation of states. Let us see how we have to treat this equation under different conditions. Okay. So when you consider low pressure, this is one condition. Low pressure. How we can consider the Vander Waal equation of states at low pressure? Okay. So here we know the relation P is proportional to 1 by B. Okay. So when pressure is very low, volume is very high. Is it clear? So when pressure is very low, volume is very high. So then we can write the Vander Waal equation of states like this. P plus A by V square into V is equal to RT. Is it clear? Here we have neglected B at low pressure. B relation, we can say that at very low pressure the volume is very high. Okay. So when compared to that much of high value, the value of B is negligible. So we can remove the value of B from this. So we can write the equation like this: P plus A by B square into B is equal to RT, where it is at low pressure. Okay. So when you consider with high pressure, at high pressure, the same relation we can incorporate here. P is proportional to 1 by B. Then we can write the equation like this: P into V minus B is equal to RT. So here we have neglected A by B square, because at this condition the pressure is very high. So the added attractive forces has no significance at high pressure. So then equation will become P into V minus B is equal to RT. Being at very high pressure, volume is restricted, so the B has significance. So we have continued with this: P into V minus B is equal to RT. This is a Vander Waal equation of states at high pressure. Is it clear? Let us see the another condition. At high pressure and temperature. Okay, here it has no much significance, because at a high pressure and low temperature, PV is equal to R. Okay, so let us see the important things regarding this. This equation is said to be Vander Waal equation of states. How this equation derived? By collecting proposed pressure and volume in ideal gas equation, Vander Waal derived this equation. Is it clear? So when we have studied and when we have considered at under different conditions at low pressure and high pressure, Vander Waal equation can be written like this. Okay, so this is about Vander Waal equation of states. Thank you.